Okay, let us start with electric field. So I'm coming to the next concept, which is electric field. Now, what exactly do we mean by electric field? To understand that, let us first consider that we place a charge in space. We can consider this charge in free space or in vacuum. Here, Q represents a charge which is placed in free space or in vacuum. And now, if I bring a test charge, we will define about this test charge as well as source charge in the next part. So here I'm bringing a unit positive charge very close to Q, and it is seen that as soon as it is placed very close to Q, it starts experiencing a force. And you place it anywhere around the circumference of the circle, we see that the force experienced by this test charge or this unit positive charge is going to be the same. So it experiences a force in the outward direction as shown in the diagram. And right now we know in which direction this charge is going to get repelled. Now let us consider I place this charge at a point a little farther from Q. It is known now this charge should start experiencing a force in a direction which is again pointing outwards. But the most important thing to find out inside this is the magnitude of force in the second part decreases. As you all can see, in the first case, the magnitude of force is greater. In the second case, the magnitude of force decreases. And now, if you take Coulomb's law expression, it is known that this force decreases. Reason is force is inversely proportional to the square of the distance between the two charges. Hence, the magnitude of force decreases as a charge is placed away from the charge which is producing the field around it. And now, if I place this unit positive charge a little farther, it is seen that it experiences a force which is much less compared to the previous two examples. So as you start moving away from the charge, it experiences little force, or you can say lesser force. Hence this Q naught when placed at a larger distance should experience very less force, or you can say minimum force, and it completely depends upon the charge of the stationary charge, the magnitude of the stationary charge. Hence this charge which is stationary placed at point O is producing a field around it, or there is a region around the charge in which another charge would experience a force. Hence this region or the space around this charge which is placed at O is known as electric field. So we define electric field as the region around charge particle within which a force would be exerted on other charge particles and is known as electric field, where we define what is a source charge. So the charge due to which the field is produced, or the charge which produces a field around it, is known as the source charge. So from our examples we know that Q over here represents the source charge, and test charge is the one which experiences the effect of the source charge. So the test charge usually experiences the force due to the source charge. So Q naught over here represents the test charge, which we have considered to be a small unit positive charge. So we define electric field intensity or electric field strength. I hope all of you know that intensity is nothing but strength of electric field. So to measure the electric field intensity, we would say that it is the force experienced by a unit positive test charge at a given point. So let us assume Q is the source charge, and if Q naught is placed at a distance close to it, we know that Q naught experiences a force, where this force is in a direction where it shows that it is repelled in other direction, since both of them are positive charges. So it experiences a repulsive force. And mathematically I can now say this electric field is given as force upon Q naught. where F represents electrostatic force between the two charges, which can be obtained using Coulomb's law. In vector form, the same equation is written as vector E is equal to vector F upon Q naught, where all of us know that electric field and electric force or electrostatic force, both of them are vector quantities, and Q naught. Let us consider the direction of electric field intensity. To find out the direction of electric field intensity, I am considering a source charge which is placed at point O. And if a test charge is now placed in the region or the space around the source charge, we know this source charge produces a force on the test charge, where this force is usually in the outward direction, or you can say there is a repulsive force between these two. As known, the direction of electric field depends upon the force that is experienced by the test charge. Hence, the direction of force also gives you the direction of electric field intensity. So you can directly come to a conclusion saying that the direction of electric field due to a positive source charge is always outwards. Similarly, I can now consider a negative source charge placed at a point, and if I now bring a test charge very close to it, it is known that it experiences an attractive force. Hence, this test charge now is attracted towards the source charge, which shows the direction of electric field. Hence, for a negative source charge, the direction of electric field is towards it, or we can say is inwards. Hence, I can conclude this saying that for a positive charge, electric field is always pointing outwards, and for a negative charge, the electric field is always pointing inwards. Force on a charged particle Q naught in an external electric field E. To find out this, let us say I have a uniform electric field which is moving from the left towards the right of my screen. And if I now place a charge in this electric field, we know this charge experiences a force in the direction of the electric field. Hence, we can come to a conclusion saying that electric field is equal to force upon unit value of the charge or test charge. Hence, it is defined as force per unit charge. Or you can even write F is equal to Q naught into E. Please note that the SI unit of electric field is found as follows, where electric field is given as force upon charge. We know SI unit of force is Newton and SI unit of charge is Coulomb. Hence, you can write the SI unit as Newton per Coulomb. To find out the dimensions of electric field is given as force upon charge, which should be E, and dimensions of force is mass into acceleration. Hence, mass is m1 and acceleration is L1 t minus 2. And for charge, it is ampere into time, that is current into time. Therefore, A into T. Hence, we can get it as E is equal to m1 L1 T minus 3 and A minus 1, which should be the dimensional formula